Warning: read and follow all labels and the owner's manual. Regulator burnout is a potential hazard with oxy-fuel equipment. Understanding what a regulator burnout is and how to prevent it is important to avoiding injury or damaging equipment. Let's take a look at the construction of a regulator. A regulator has an oxygen inlet that leads to the high-pressure side of the regulator. The regulator contains a seat that acts as a valve between the high and low pressure sides of the regulator. The low pressure side of the regulator connects to the hose which leads to the torch. When you turn the regulator adjusting screw, it allows oxygen from the high pressure side into the low pressure side of the regulator, controlling the pressure. This is how the regulator is used to control correct pressure in the system from the regulator into the hose and to the torch being used for operation. There are 3 different ways regulator burnout can occur: dust and oil regulator burnout, dissociative gas regulator burnout, and mixed gas regulator burnout. As oxygen flows from the cylinder into the regulator, pressure builds and presses up against the seat inside. As the oxygen presses up against the regulator, the pressure is energy that creates heat. When the cylinder is opened too rapidly, oxygen can build up too much heat while it is escaping from the cylinder and recompressing into the regulator. This is known as the heat of recompression. If dust or oil is present in the cylinder valve, it can enter into the system with the oxygen on the high-pressure side of the regulator where pressure is building. When dust or oil is pushed through the regulator with the oxygen, it acts as fuel in the system as heat builds, allowing for combustion to occur, known as a dust-oil-oxygen regulator burnout. Smith regulators have a unique dual filter design, including Sure Seat, as well as a tailpiece that can help in preventing dust and oil regulator burnouts. The regulator's dual filter protects the high-pressure seat from debris for reliable operation and longer service life. The next type of regulator burnout is dissociative gas regulator burnout. Let's look at how an acetylene cylinder is constructed. First of all, the cylinder itself is filled with a porous, absorbent material which is then saturated with liquid acetone. These components help keep the gas stable under pressure in the cylinder. The acetylene gas is then added to the cylinder and absorbed by the liquid acetone. As it gets used, the acetylene gas is released from the liquid acetone. Dissociative gas regulator burnout occurs when acetylene is used at too high of a pressure. When the pressure is greater than 15 psi-G flowing, the acetylene molecules break within the regulator, causing a dissociative explosion. The next type of regulator burnout is the mixed gas regulator burnout. Mixed gas regulator burnouts occur when cylinders are used at too low of pressure, when they are almost empty. If the cylinder is empty, there is not enough pressure pushing back on the seat from the low pressure side of the regulator. Low pressure on this side allows the high pressure side to reverse flow and push its way back into the empty cylinder, causing the gases to mix. Combustion can occur anywhere the gases are mixed, so it is important to never allow a cylinder to completely empty to avoid a mixed gas regulator burnout. Never allow cylinders to empty completely. Never use oil on your regulator. Never use an oxygen cylinder that has oil or grease on the valve. Never use an oxygen regulator on anything other than an oxygen cylinder. In order to prevent regulator burnout, keep the regulator clean and free of dust and oil, and keep it out of the regulator. Before connecting the regulator, crack the oxygen valve to blow out any debris to ensure it is clean. Then, crack the cylinder slowly. Be sure to use proper startup and shutdown procedures. Purge the system before you begin. Before starting, open each valve individually for 3 to 5 seconds to purge any flammable gas mixtures out. Be sure to check out the rest of the videos in our How-To video series to learn how to safely and effectively operate oxy-fuel equipment.